Thank you. Good afternoon. I would like to tell you something about porting embedded projects. A few months ago, I needed to revive my project from university. This project was communication, microcontroller communicating with GSM modem, and I needed this. However, I didn't have the tools, the IDE, that would allow me to build the firmware for this board. So in the years after the university, I've learned that there's enough open source tools to make, let's say, open IDE. So instead of manually dragging the files from the old closed source IDE, I thought, hey, it would be great if there was some script that would just convert the project from one IDE to another. And that's what I would like to tell you today. So, first of all, I'll talk about what's an embedded project. Although in the morning there were quite a few of you that raised your hand that they are quite familiar with embedded development. I will show you which open source tools I used and how Python helped me in a demo. So, what's an embedded project? Usually it involves a microcontroller or a microprocessor. This can be something as simple as 8-bit microcontroller, so something like AVR, PIC, or maybe 16-bit MSP430, or some ARM 32-bit microprocessor. Common to all of these microprocessors is that they have limited resources. There's not much RAM and flash, so the code can't be that big. And there is also a limited number of IDEs and the options in them. So, what are the issues when you are using these IDEs? If, for example, one IDE doesn't support the board that you are currently using, and the other one does, and you have already created a project, then you need to manually start from scratch in the other IDE. Also, you are usually not allowed to use different tool chains to build the firmware. They are not open source, so if you want to modify them because there's a bug, you need to contact the developer of the IDE, the company, report that bug, and the solution for finding some patch can take some months, so you need to rely on the vendor. And sometimes it can miss some features. For example, the code editor in IDEs is somewhat poor compared to open source alternatives. And it's also hard to customize. So, the idea behind this, let's say, script that would convert the project was this website. Do you know it? Zamzar? It allows you to basically convert a variety of files into different formats, for example, documents or audio files. So I thought I can use Python, write some script, parse the configuration, and write a new configuration for the IDE that I wish to use. So, what do I need to export? Do you have any ideas? Are there any embedded developers still here? Okay. No idea. Okay. Then I will tell you. So, source and header files, of course. Then some information about the target. What kind of target do I have? Is it 8-bit? How much memory do I have? And so on. Some build and the debug settings, how to build the firmware, and what kind of debugging hardware to use. So, I haven't mentioned that the project was on STM32. It's a 32-bit microcontroller. The core, it runs on ARM core, Cortex-M. This one is F3, so it's M4 core. And when I was at the university, I used two IDEs to write the program. It was IR Embedded Workbench, and the other one was Keil Microvision. Of course, there are other IDEs, but I developed the program in these two, so I focused only on these. So here you can see a structure of a simple program that I will later show you in a demo. You can see that you have there some directories. The directory drivers has drivers for the peripherals. Then there is the eWarm. It has the project settings for the IR ID. Then there is include directory. Here are the header files. Then there is MDK ARM. This is for Keil ID. And lastly, we have the source files. So when we look at the IR project settings, they are stored in XML file. So you can see that the file is, let's say, very well described. So what kind of modules can I use in Python to parse XML? Do you know any modules? Yes. And there's even simpler module. It's called Objectify. And it allows you to get the values from the XML file in a really simple matter. So I just traverse the XML structure in a dot manner, in object manner. So now I've parsed the file, and I need some tools that will allow me to build actually the firmware. So one of these tools is GCC. It's a compiler toolchain. It's open source and cross-platform. There is the C compiler, assembler, linker for C, and C++ and other languages. And it also supports multiple architectures. Then there's the CMake, which allows you to build or to specify the build process. It's also open source, cross-platform. And the advantage of using CMake is that you can then include the entire project into, let's say, Eclipse or CodeBlocks or other graphical IDE. However, to create this CMake file, I need some module that will simply allow me to generate the file based on some template. And for this, I use Ninja. Do you know Ninja? Okay, so some of you know. That's good. It's a templating engine. It supports Unicode, and if you are familiar with Django, I think some of you might be. The templating system is heavily inspired by Django's. And the reason why I chose this templating engine is that it has a great community and also documentation. So here you can see an excerpt from CMake.py script. You can see that I have here dictionary. I assign it some values. Before that, I've, of course, imported the Jinja module. And then I just prepare the environment. That means I say, I specify the template folder and some other options. Then I select the template inside the template folder. And then I pass the dictionary to the template and ask it to render the file. Here you can see the template file. So these variables will be at the end replaced by the values stored in the dictionary. You can see I can either paste there one value, or the templating engine supports also for loops, so I can generate a whole set of lines of code. And now for the demo. So I have here the directory with the project, and then here in the command line I have here all the scripts. So there's the converter.py, which is responsible for scanning the entire root directory and finding the proper project settings. And then there are special scripts for parsing either IR or Keil. That's the EWP project and UVP project. And the last file is CMake.py, which is responsible for generating the CMake list file. And also there are the CMake list template and stm32flash.ld, which is a linker file. So in order to generate the project, I just run the converter and I tell it the directory, where is the project, and I select if I wish to use IR or Keil configuration. So it parses it and fills the convert demo directory with CMake list.txt and stm32flash.ld. And then I just switch to this directory, run CMake. Oh, sorry, I forgot to specify the name. you can see that the CMake did its job and created makefile and some other directories. And now I only need to type make, and it builds the entire project. And now I just flash the project to the board. And that's it. So, as I said, this project is still under construction, and there are some improvements that can be made. For example, one thing you can't just take from your project is startup file, which is written in assembly language. So you need to pass it the correct startup file for the toolchain that you selected. Then there's also always more microprocessor architectures. Currently, I'm supporting just the STM32, but there's no reason I can't make, for example, support for 8051 or PIC or something else. I can add support for more IDEs. That means either closed source or open source. Compiler toolchains. And for the Python part, it would be also nice to write some unit tests because it's quite a complex project. So it would be good to have a unit test harness and prepare a Python package. So thank you for listening. And if you like this or you just wish to pick or contribute, you can find the repository on the GitHub.
Right, thank you. We have some questions. Can you recommend any resources for Arduino guys that want to enter the STM32 world?
There's STM32 Duino, which is Arduino firmware running on STM32, which would be the best way to, let's say, switch from Arduino to STM32.
Thanks. And you mentioned Jinja has a great community. Can you elaborate on what makes it great?
It was really simple to use it, for me, at least.
Hey,
I managed to learn it in 1 hour.
Okay, thank you. Do we have any more questions?
Thank you. We are working with Atmos Studio. Do you have any experience with it, and would it be hard to add it to your project?
I have no idea. I've worked with Atmos Studio a few years ago, but I don't know. May I ask which kind of microcontrollers are you using?
Cortex M4 free.
So some SAM chips.
Yeah.
Okay. Well, if it's XML file, then it will be really simple. You just add there some Atmos Studio project.py file that will parse the XML and put it into the CMake.
Yeah, but it is XML, and it generates makefile also. You have access to makefile, so it maybe would be easy.
It's also possible to generate makefiles. I just selected CMake because if you wish to use some graphical IDE, then you can import CMake because it's, let's say, standardized compared to makefiles.
Right. I have a more general question, perhaps. What kind of setup do you use for debugging? Because if you download, for example, Keil or the Microvision IDE or something like that, yeah. IR, then debugging is already built in. You can like press in an F number key, and it will copy itself into the target and start stepping, and you can like step and resume and stop the code. What kind of debug setup do you use?
It's quite simple. I use GDB as a front end. So GDB is usually built inside the IDEs. And when the GDB is starting, I just specify that I wish to use hardware backend. So I use OpenOCD, which is Open On-Chip Debugger or something like that. It's a server written in Tico. And it communicates with variety of hardware debuggers. In this case, it's ST-Link. And basically, you just run the server with the configuration of the microcontroller, and you connect from GDB to the OpenOCD. So you just say target remote localhost port 3333. You load the file, and that's it. The only thing you are now missing is the register view.
Right, and for example, your experience with OpenOCD, how many bugs does it have? Like how many times did it crash on you or not do what you told it to do?
Well, I would say it's not that easy to configure it correctly, but once you understand it, it's quite simple. And nowadays, it doesn't crash on me.
Thank you.
Any more questions? I'll take a look if... All right, if there are no more questions, and then please thank Petr.
Thank you.